Start off this video with the challenge problem from the last video. So we're going to start by summing our forces in the horizontal direction because that is the direction of our acceleration. Or I should say the dimension of our acceleration. So in the positive direction we have this horizontal component of tension. So to get that we take our cosine of theta, which is our adjacent of our hypotenuse. Our adjacent here is our force in the x direction, and our hypotenuse is the magnitude of the force, so then our force in the x direction multiply both sides by f is going to be f cosine theta. And opposing that, we have this force of friction here minus f. From Newton's second law, we set this equal to the mass of the box times its acceleration in the horizontal direction. If you're not really clear on if we have all the forces, try drawing a free body diagram, right? So that's the center of mass of the box. We've got a force here of F, we got our friction here, and then you have your normal force and the force of the Earth. This is not to scale, but right, we've got three forces that are touching the box, in contact with the box, and then the force of the Earth. But yeah, we've got all our horizontal forces in our components. So we want to know acceleration, so you just divide both sides by mass. You get f cosine theta minus the force of friction divided by the mass of the box, and that is the answer. Alright, so in this video we're going to be covering friction, and this is the equation for friction given to you by the College Board on the equation sheet. So what it's stating is that the magnitude of the force of friction is going to be less than or equal to the product of the coefficient of friction times the normal force. Now the first thing that might jump out to you is that inequality. So to understand the inequality, you need to know two things about the coefficient of friction. The first one is that it could be the coefficient of static friction, and that is used when the object is still, so static for still. And the second one is mu sub k, which is the coefficient of kinetic friction. So mu s is going to be greater than mu k. Now what that says is that it is more difficult to accelerate an object from rest than it is to keep that object in motion, which you may know from experience. So a more useful way to write this equation would be to say that the force of friction equals the coefficient of friction times the normal force. So for a quick example problem, let's say we have a block on a surface. We'll just say it's in motion, and because it's in motion, it's going to be a coefficient of kinetic friction. We'll say that equals 0.1. And coefficients here, they don't have any units. So we're going to say this block is 2 kilograms, and we want to know what's the force of friction. Now notice that the force of kinetic friction does not change while the block is moving. It doesn't matter how fast the block is moving. So we'll say the force of friction is going to be the coefficient of 0.1 times the normal force. So let's draw a free body diagram. Let's say the block is moving to the right, so friction is going to be to the left. Contact with normal force and the force of the Earth. Alright, so to find the normal force, we need to sum the forces in the y direction, and there is no acceleration in the y direction. So because there's no acceleration in the y direction, the normal force has to equal the force of the earth, which is equal to the weight of the block. Right, so 2 times 10 is 20. And then we are left with the force of friction is going to be 0.1 times 20, and that is going to equal 2 newtons. Alright, now let's take a closer look at static friction, which is really more of an inequality. So we have static friction, and then we also have a maximum value for static friction. Alright, so let's say that you have a very large box and you are trying to push it across the floor, right? But the box isn't moving. So maybe you start by applying a force of 5 newtons and it's not moving, and then you apply a force of 10 newtons and the box still isn't moving. Right, so let's sum the forces in the x direction. Because the box isn't moving, there's 0 acceleration, therefore the force is summed to 0. So that means whatever force you are applying, F sub A is equal to the force of friction, right? And if the force that you are applying is growing, then the force of friction opposing that has to also be growing to keep that box stationary. And that is why we have that inequality there. For our first problem, we have a 5 Newton force moving a 5 kilogram box to the right. That means it has its velocity to the right. The value for the coefficient of kinetic friction is 0.2. Which of the following is true of the motion of the box? So notice that all of these options have to do with acceleration. So hopefully immediately you see one we can cross out, and that would be option D. The only difference between speed and velocity is magnitudes, and that does not have to do with acceleration. In fact, option D is impossible. So now let's figure out the direction of acceleration first by defining a positive direction. We're going to choose that to be to the right because that's the motion of the box. So now we're going to start by summing our forces in the horizontal direction. So we have a 5 Newton force in the positive direction, and if we were to draw a free body diagram just for the horizontal direction, we would have our applied force, and opposing that is always going to be friction. Alright, so we know our equation for friction. Because the box is in motion, we're going to have the value for kinetic friction times our normal force. And if we add in our vertical free body diagram, we have our normal force up, force of the earth down. So normal force is equal to the weight of the box. Right, so plug in those values. You've got 0.2 for the kinetic friction times a normal force of mg, so 5 times 10, and that should give us 10, and that's going to equal ma. You can find a by dividing by the mass, but that's really not going to change the direction. So take 5 minus 10, divide by 5, and you're going to get a value for acceleration of negative 1 meters per second squared. Right, so again, this is just 0.2 times 5 times 10. Normal force is mg. Alright, so what is this negative 1 meters per second squared telling us? Well, positive is to the right, negative is to the left, and our acceleration is negative, so we have an acceleration to the left. Here is very much an AP-like style free response question, so I really encourage you to pause the video and try it on your own. You absolutely can do this. Remember to sum forces. We're going to define the system here to be the 2 blocks, but definitely go ahead and give this one a try. Alright, so the first thing I want to tell you is that fundamental constants, it's just typically gravity. So we're going to start by finding the acceleration of the two block system because both of these blocks are going to have the same acceleration. So acceleration is going to equal F over the mass of the system, and this is F net. So in the direction of motion we have our force F minus friction. You cannot forget friction here. So friction we know is mu Fn. Alright, we know mu is just mu. And the normal force is going to be the mass of the block, so that is 5m times the force of gravity. Right? And that is divided by the mass of the system being 5m. Right, and you can rewrite that as F over 5m minus mu g. Alright, that's our acceleration for the system, and if you can simplify a fraction like this one here, definitely try to. Sometimes it makes the algebra a little bit easier. Alright, now we want to find the force accelerating the smaller mass. Right? Now there is a force of friction between all surfaces. So there's going to be one right here. So there's a mu here. And I should have drawn a tabletop or some surface under the forearm. But there's also a surface here that also has mu, because it says there is mu between all surfaces in contact. So that would probably be something you would underline. So that is going to be F. I'm going to put F sub s for smaller mass. That's going to equal the mass of the smaller mass times its acceleration. We know its mass is m, and we have a nice little formula here for our acceleration. So we take F sub s is going to be m times acceleration, which is F over 5m minus mu g, multiply out, and we're going to get F over 5 minus mu mg. That is the answer. So I would probably put a box around that. So what it says is that the force accelerating the smaller mass is 1/5 of the total force minus the force of friction acting on that box. Alright, so a couple quick things I wanted to point out for questions like this that you will most likely definitely see on any practice AP exams that you do or the exam itself is that pretty much all of the problems are going to be variables that you're solving for. You're not actually going to be putting in and solving with numbers. So become comfortable with working with variables. If you have a question that maybe you're working on for homework that has numbers, substitute in variables for those numbers, solve for the variable that you're trying to solve for, and then plug in the numbers just so you get used to working with letters or symbols. Second is that there will typically be multiple parts to these questions, like A, B, C, D. It wouldn't just be like this one. So a lot of these parts, before you get to the final part, are setting you up to solve for the final part. But maybe you missed part A, but you can still get partial, if not full, credit for part D. And if you see something that says fundamental constants, typically that's like the force of gravity, and that would just be a G. And you should also always use the variables they give you. Don't come up with your own variables, because they will be looking for their variables when grading your response. Alright, here's another AP style question. I really encourage you to try to start doing these problems on your own and then coming back to the video to see if you got it right. So this time we're told to solve in terms of given variables and fundamental constants. That just means any variables that are in the block of text or on any diagrams that you're given. And diagrams are super helpful. Always, always, always analyze the diagrams carefully. So we want to find the maximum force that can be applied before this lower block starts to slip. So I'm going to do a little bit different type of free body diagram. Instead of using a dot for the center of mass, I'm going to copy that block on its own. So then I'm going to draw the forces where they're applied on the block. So to determine the direction of the forces of friction, imagine just having one sheet of sandpaper on the top and one sheet on the bottom. If you were to then pull the block between those forces, those pieces of sandpaper, where would the forces of friction be pointing? Well, we know the bottom one is going to be opposite the direction of the force, and so will the top one. So this block is sandwiched between two forces of friction. Alright, so before that lower block starts to slip, that big F is going to be equal to both of these forces of friction. Alright? So that is when, now usually F is going to be between, or you could say F is going to be less than or equal to the forces of friction. Alright? Right, because this is static friction. Static friction doesn't have a set value. It grows up to a maximum value, and then it transitions into kinetic friction, which is less than static friction. So before, when these blocks aren't slipping, as F grows, it's going to be less than F until eventually big F comes to equal little f. And that's what we want to solve for. And this would technically be the sum of the forces of friction. Alright, so we know that F is going to equal F1 plus F2. Right, so what is F1? That's just going to be mu times the normal force. What is the normal force here? Well, F1 is going to be acting right here. Normal force is going to be 4 mg. Right, because you've got both blocks on top. So when you're analyzing F1, just think of this as one big block. Plus F2, which is, again, we got a coefficient, because F equals mu Fn. So this right here is where F2 is acting. So the normal force there is just going to be 3 mg. Right, so if you add those up, you're going to get 5 mu mg. That is going to be the maximum force before the lower block begins to slip, and we're just assuming that the force of tension is large enough to not break before we reach that maximum value. So you just box your answer up, and then you're done. Alright, here is the challenge problem for this video. Definitely please draw a free body diagram here. It will help you tremendously in solving the problem. The solution will be on my Instagram page about 24 hours after the release of this video. Link in the description, or you can find it at the beginning of the next video. Good luck.